Imagine waking up one normal morning. The sky looks the same, the sun rises on time, birds still fly. Nothing feels different. But far beyond Neptune, something impossible has happened. Earth's orbit has slightly changed. Not enough for alarms, not enough for panic, yet. Somewhere in deep space, an invisible giant has appeared. A black hole. Not close enough to swallow us instantly. Not dramatic. Not like the movies. Just close enough to begin rewriting reality. Before we understand what happens next, we need to clear up one big myth. Black holes are not cosmic vacuum cleaners. They don't roam the universe sucking everything in. In fact, if our sun were suddenly replaced by a black hole of the same mass, Earth would continue orbiting almost normally. Gravity doesn't change. What changes is what happens when you get too close. Now let's imagine the impossible scenario. Earth somehow begins drifting toward a black hole, slowly, silently. At first, nothing seems wrong. Days pass, weeks, even months. From the surface of Earth, life continues as usual, but astronomers notice something disturbing. The stars near the black hole begin to bend. Light itself curves, forming strange glowing rings in space. This is gravitational lensing. The black hole isn't visible, but its presence is unmistakable. As Earth moves closer, our planet begins to feel tidal forces. These forces don't pull everything evenly. They stretch. On one side of Earth, gravity is stronger. On the other side, weaker. The planet begins to deform, very slightly at first. Oceans respond before land does. Tides grow stronger than anything in history, not meters, kilometers. Entire coastlines flood, then retreat, then flood again. Earthquakes increase as the planet's crust struggles to stay intact. Still, Earth hasn't crossed the point of no return. Yet. As we approach closer, the sky changes. The black hole's accretion disk, superheated gas and dust spiraling at near light speed, begins to glow brighter than any star. The night sky is no longer dark. It burns. Radiation levels increase, but not instantly lethal. Satellites fail first. GPS goes silent. Communication becomes unreliable. Time itself begins to behave strangely. According to Einstein's theory of relativity, the stronger gravity becomes, the slower time moves. From Earth, we don't notice it immediately. But an observer far away would see something horrifying. Earth's clocks are slowing down. Our seconds stretch. Our minutes grow longer. We are falling, but we don't feel like we are. Now comes the most misunderstood part, the event horizon. This is the point where escape becomes impossible. Not even light can return. From far away, Earth never seems to cross it. We appear frozen, dimmer, redder. This is called gravitational redshift. Light loses energy trying to escape. From our perspective on Earth, however, we cross the event horizon without fanfare. No wall, no explosion, no sudden darkness. The laws of physics still work, at least for now. But the universe outside is gone. There is no back. Inside the black hole, space and time swap roles. Moving forward in time becomes as unavoidable as falling downward. There is no stopping. Now tidal forces become extreme. This is where spaghettification begins. Earth is stretched vertically and compressed horizontally. Mountains flatten, oceans tear free from the crust. The planet elongates into a stream of matter. Atoms are pulled apart. Molecules don't survive. Eventually, even the concept of Earth ceases to exist. But what happens next is unknown. At the center of the black hole lies the singularity, a point of infinite density, infinite gravity, and zero volume. This is where our equations fail. Physics breaks. Some theories suggest everything collapses into nothing. Others propose something even stranger, that black holes may be gateways to another universe, another region of spacetime, or a rebirth through a white hole. There is no proof, only mathematics and mystery. From the outside, Earth is gone. Its information may be preserved on the surface of the black hole, encoded in quantum fluctuations. This is known as the information paradox. According to modern physics, information cannot be destroyed. So somehow, Earth still exists, not as a planet, but as data written into the fabric of the universe. So what would happen if Earth entered a black hole? There would be no dramatic instant death, no sudden end, just a slow, inevitable descent into the most extreme environment that exists. A reminder of how fragile reality is and how little we truly understand. Black holes are not just destroyers. They are laboratories of the universe, places where nature pushes itself beyond limits, and perhaps places where new universes are born. The most terrifying thing about black holes isn't that they destroy worlds. It's that they force us to admit something far more unsettling, that the universe is deeper, stranger, and more mysterious than we ever imagined. And we are only just beginning to understand it.